Hello, my name is Trent. In this project, I built a machine learning model to predict the electrical energy output of a combined cycle power plant using historical environmental data. The goal was to see how accurately machine learning could forecast output based on conditions like temperature and humidity. This was a regression problem since we're predicting a continuous value, power output, measured in megawatts. I used Google Vertex AI to build the model without needing to code, which allowed me to focus on decision-making process rather than the technical implementation. The input features I used were ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. The target I was predicting was net hourly energy output in megawatts. Vertex AI handled the training process. It automatically split the data into training and validation sets, evaluated multiple regression models, and selected the one with the best performance based on error metrics. This approach helped me focus on framing the problem, choosing appropriate inputs, and evaluating model quality. The final model achieved an R-squared of 0.963, which means it explains over 96% of the variation in power output. It also had a mean absolute error of 2.48 megawatts, which is a small margin of error considering the output range is typically between 420 and 495 megawatts. Finally, the model scored a 3.218 root mean square error, meaning that the bigger misses were just around 3.2 megawatts. This tells me the model is quite accurate and could be useful for forecasting or operational decision support. I find this feature importance bar chart interesting, as it visually depicts how much more temperature affects energy output compared to the other features. These findings do make sense. Temperature does affect thermal efficiency, and the second influential or most influential variable, vacuum, also plays a role in steam expansion, which impacts output. The model turned out to reflect real-world dynamics, making it trustworthy, which is something I'd strive for in any AI-powered product. I can only imagine how critical it must be to have dependable predictions in such a high-stakes energy systems. As someone without a data science background, I used Google Vertex AI and guided support to walk through the modeling process. I'm still learning how to interpret some of the individual results, especially when it comes to connecting statistical outlets to the real-world mechanics of a power plant. This experience gave me a clear view into how machine learning can reflect system-level behavior and reinforced how important it is to collaborate with domain experts when applying AI to complex environments. And speaking of collaboration, I'd like to make sure I acknowledge the technology that helped me through this project. Google Vertex AI for model development and my virtual coach ChatGPT, which helped me interpret the modeling process through a product and UX lens, making a very complex topic accessible, honest, and practical. Thank you.